Branches of chemistry. Following are the main branches of chemistry: physical chemistry, organic chemistry, inorganic chemistry, analytical, biochemistry, nuclear, industrial, and environmental chemistry. These are the certain branches of chemistry. The first three being the basic branches of chemistry: physical, organic, and inorganic. These are the basic branches of chemistry. We'll study them one by one. First, physical chemistry. Physical chemistry is the branch of chemistry which deals with the relation between the physical properties of substances and their chemical composition and transformation. For example, the physical properties of substances is water is liquid. The table in front of you, LCD or book in front of you, is solid. These are the physical properties of substance, while its chemical properties would be for example, salt is soluble in water, while sugar is not soluble in water. It is only soluble in water if it is heated. There are some chemical composition and transformation. For example, if you mix salt and water, they'll mix easily, but if you mix sugar and water, it won't mix easily until and unless you heated the solution. Now these are certain properties. They relate to the chemical composition of substances. Due to these composition, the physical properties also change. We will study the physical properties of substances, the chemical composition of substances, and how they transform if with respect to each other. If we apply some changes, what will these changes result in? This is physical chemistry. Second is organic chemistry. It is a branch of chemistry in which we study the compounds of carbon and hydrogen called hydrocarbons and their derivatives. However, some simple compounds of carbon like carbon oxide, carbon monoxide, carbon dioxide, carbonates, bicarbonates, cyanides, etc. are not studied in this branch. We study hydrocarbons, hydrogen, carbon, and hydrocarbons in this organic chemistry. Everything that is carbon and hydrogen called hydrocarbons, will study them in organic chemistry, but not like carbon oxide, carbon monoxide, carbon dioxide. You will see that they don't have hydrogen in it. They do have carbon, but they don't have hydrogen in it. In organic chemistry, everything other than organic chemistry is studied in inorganic chemistry. It deals with the study of all elements and their compounds except hydrocarbon and their derivatives. Organic chemistry, as hydrocarbons are the most basic components of living organisms, so we study mostly in organic chemistry, we study the living organism. Analytical chemistry. Analytical chemistry, the word analytical is derived from analysis. You'll see that most of the analytical chemistry is about analysis. This branch of chemistry deals with the qualitative means it deals with the quality of certain substances, and quantitative means the quantity of substances. Qualitative and quantitative analysis of the matter. Qualitative means what kind of atoms, molecules are present, and quantitative means how much mass and the number of these atoms or molecules are present. You have certain solution. If you study the quality of the solution, the quality would be what kind of atoms, molecules are present. For example, if their solution does that solution contain water molecules? Does that solution contain salt molecules, sugar molecules, etc.? And how much mass and the number of these atoms or molecules are present? These type of analysis are studied in analytical chemistry. Biochemistry. You'll see that most of these branches, the name defines what we do in these branches of chemistry. For example, biochemistry, you will realize that it is related with the living organism. In this branch of chemistry, we study the synthesis and decomposition of the compounds in the reaction which occur in the living organisms such as plants, animals, and human beings. For example, when you eat food, you see that this food gets digested into in your stomach. Now, how does this digestion occur? What are the chemical processes that result in the digestion of your food, and how is this how does it help you? How are these molecules, these minerals, these atoms, they are transferred to your blood, etc., etc. You'll see many processes, many chemical reaction. There is a famous chemical reaction called photosynthesis. You may have heard about it in your previous classes. These type of things, they are related to biochemistry. They are studied in biochemistry. For example, photosynthesis and respiration. You will study in your later classes that photosynthesis and respiration, they are exactly opposite of each other. One occurs in plants while the second occur in living organism. Respiration also occur in plants, but photosynthesis occur during daytime while respiration occur during nighttime. And photosynthesis doesn't occur in living organism like animals, but it occurs in animals only. Nuclear chemistry. Nuclear chemistry is a branch of chemistry which deals with the study of the changes occurring in the nuclei of the atoms, accompanied by the emission or absorption of radiation. You'll study the structure of atom in later topics. There is a center of atom is called nuclei. It has protons and neutrons in it. Now that part of the atom is called nuclei of the atom. Now you will study that these what changes occur in the nuclei of the atom by the emission or absorption of radiation. Industrial chemistry. Industrial chemistry is a branch of chemistry in which we study the techniques and chemical processes for the preparation of different industrial products like cement, glass, plastics, fertilizer, etc. Now, most of these products that you see in your market that you use, the spices, the cement, glass, plastics, edibles, etc., etc., they are prepared in industries. In industries, we have chemists that study the formulas, the different chemical processes that result in these final products. A cement isn't something that is found naturally in environment. It has certain formula to it. A certain chemist make it by using their formula, while another chemist will make it by using his formula. We'll see that certain cements are stronger while having more quality than the others. Chemists in the industrial areas, in the industries, they study the different processes, different chemical processes in making of these products. A glass manufacturer would want its chemists to study the glass to improve its quality, to improve its durability. Like plastic, you'll see that plastic is it cannot be destroyed. It cannot be recycled unless you use it to make more things. It cannot degenerate, like you'll see it cannot decompose. You have seen plants, animals, etc., etc. They do decompose with the passage of time, while plastics like these things, they do not decompose. It is so that's why it is harmful for the environment. You'll see that the chemists would try to improve. They would like to come up with certain formulas that can help in the decomposition of the plastic, which would eventually help in the decomposition, and they'll help in removing pollution, etc. Environmental chemistry. It is the branch of chemistry that deals with the interaction of chemical substances, processes with the environment and their impact on it. Air pollution and water pollution are the two main areas studied by environmental chemists. Environmental chemists, they study different processes, different chemical processes that, for example, you will come to know in your later studies that carbon monoxide, it is very dangerous for the environment. It is dangerous for the O2, ozone layer is depleting. It is these reactions, the reaction that occur which results in environmental pollution. Chemists try to reverse them. They try to reverse them by coming up with new chemical processes. For example, you will see that previous cars that they would emit certain smoke which would result in very harmful gases. Now the new cars, they have certain parts which enable this, which filter the smoke and emit less harmful gases. These are certain things that environmental chemists work on. Science, Society, Technology and Science. In 1965, a research group in the former USSR headed by a B.V. Daryagan reported that they had discovered a new form of water. They described the experiments performed and listed several properties of this new water, which was named Water 2. Among other characteristics, Water 2, called poly water by other research groups, was reported to be about 1.5 times more dense, heavier than normal water, and its ability to flow through pipes was said to be 15 times less than that of the normal water. The report caught the eye of the many people in chemistry because it was very interesting and totally unexpected. Several research teams immediately set out to make polywater for study in their own laboratories. Following the directions given in the original report, they produced a liquid which looked like the substance described by the original investigators. After careful analysis, it was concluded that the liquid was nothing more than impure water. When this finding was reported, a fascinating interchange between the investigators took place in the chemical journals regarding who was correct. Finally, many other investigators, after performing experiments, supported the conclusion in favor of impure water. It is not that the scientists believe that the new reports are false until proven otherwise, but rather that they suspend the final judgment until the reports have been verified. You see, these type of things, they strengthen our beliefs in the science. Previous scientists, they used to study ways in changing base metals into gold. After many years of research, scientists realized that it cannot be done. It cannot be done because gold is an element and you cannot change a certain element to another.